Hello everyone. Welcome to the solution of LeetCode problem 704 named binary search. In this problem, we are given an integer array and a target is given. We have to determine whether this target value is presented in the integer array or not. If the value target is presented in the integer array, we have to simply return the index number. Otherwise, we have to simply return -1. Now, we have to write an algorithm that runs in big O of log n time. That means which is the binary search. Now here in the first example, you can see that the array contains several elements and the target is 9. So here we can see that the 9 is presented in the array in the index number 4. That's why you have to return 4. Now here we have seen that the array contains several elements and the target is 2. That's why we have to determine whether this value 2 is present in the array or not, but unfortunately it is not present. That's why we have to return -1. I hope you understood the problem statement. Now let's move on to the algorithm. Now let's take these examples here. This is our array and this is our target. Target is 10. So we have to determine whether the value 10 is presented in the array or not. Here, the value 10 is presented here in the index number 9. So here we have to return 9. Now, how to implement this algorithm? In this binary search algorithm, we will take several algorithms or several pointers. It is the first pointer, which is here, and it is the last pointer, which is here. Now, the first pointer is the start pointer, and the last pointer is the end pointer. Now here, we have to check what is the minimum or the mid value of the both of the pointer. Here, the mid value will be 0 plus 11 divided by 2, which is 5. That means this is the mid value. So far, so good. Now the basic intuition is we have to check whether our target element is equal to the mid value or not. If our target element is equal to the mid value, that means we have to simply return the mid values index. Otherwise, if our target element is greater than mid value, that means we have to search the target element in the right direction in this range. Or if our target value is less than mid value, that means we have to search the mid target into this direction or into the left direction. Why so? Because if suppose here target value is 10, so which is definitely greater than 5, that means it is not possible that the value 10 is presented in the left direction because all of the element in the left direction is less than 5. Similarly, if the target is 2, we don't have to search into the right direction because all of the element in the right direction is greater than 5. So it is not possible for the element 2 to be presented in the right direction of 5. So here the algorithm is for each iteration, we have to calculate the mid value. Now we have to check whether our current element is equal to the mid value or not. If our current element is equal to the mid value, that means we have to return the mid values index number. Otherwise, if our current element is greater than mid value, that means we have to upgrade our start pointer. Now, start pointer will pointing to the mid plus 1. It will possible if our target value is greater than mid value. Now, again, another scenarios can be possible. It can be possible that our target value can be less than mid value. If it is, then our end pointer should be shift into the mid -1. So the algorithm is pretty simple. In each iterations, we have to calculate the mid value and check whether our current element is greater than or less than is equal to the mid value or not. If our current element is greater than mid value, we have to shift our start pointer. And if our current element is less than mid value, we have to shift our end pointer. Finally, if our current element is equal to mid value, we have to simply return the index number. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named search, which has a vector as a parameter and a value k. Now, this is the start index, this is the end index, and it is the index variable. Now, we have to repetitively check whether the start index is less than is equal to end or not. And inside each iteration, we have to calculate the mid value and check three conditions. It can be possible that our target value is equal to the value presented at the mid index. So if it is, that means we have to upgrade the index value and break the loop. Otherwise, if our current target value is greater than mid index value, that means we have to shift our start pointer. Otherwise, we have to shift our end pointer. Finally, we have to return the index. I hope you understood the algorithm and the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.